Yeah, good afternoon. Thank you very much for inviting us. Super happy. I'm enjoying my day. Excellent. So delighted to present this paper with only 10 co-authors. That's the second paper we write together. The previous one, we have 252 co-authors, as you will see in a second. So it's about computational reproducibility, as you can see. So the first thing we need to do when we talk about reproducibility or replication is provide the definition, because there's a lot of confusion about all those terms. So here is what we do. So this is a type of reanalysis. We try to regenerate a result that exists in a paper. So there is a reference result, which is a beta. That's the result, an empirical result in a paper, which is based on some data D, some method M, and some code C. Okay, so what we do when we test the computational reproducibility of a result, we use the same data, the same method, the same code from the original order, and we just rerun the code and check whether we find exactly the same result. Okay, some other researchers, they have a less strict definition. They use the same data code, they run it, and they try to check whether they find consistent results. Let's say same sign, same significance. Okay, although they cannot access the original code, so they have to write on their own the same code, okay, based on the same data. So this is different types of reproduction, and we focus on the first one, which is the strictest definition. This is what we call computational reproducibility. And of course, there is also replication. Can you regenerate consistent results by changing the data or changing the method or both? But we'll have some experts about replication, so I will stop here. I just want to mention that we focus on this first definition. Okay. So, and by the way, this is exactly what leading economic journals are doing in economics. You know, at the American Economic Association, Lars Willhuber is doing exactly what we do here. They try to regenerate exactly the result, and they only publish the paper if they can find the exact same result. Okay. So why it's important to verify the reproducibility? So I would say that's the very minimum we can ask to a so-called scientific result. Okay, that's a minimum. That's a minimum requirement. It's also increasing transparency, which is like the word of the day. Hence, facilitating diffusion, spreading of new ideas, facilitating again replication, reducing p-hacking, reducing fraud, boosting trust in science. It's also forced researchers to spend a little more time on their code, documenting everything, sometimes finding and correcting errors by doing so, again, increasing the quality of research. Although the definition I just gave about computational reproducibility is kind of basic, just like regenerating the same result from the same data and code, in practice, it's kind of surprisingly challenging. Existing empirical evidence is surprisingly disappointing, and we had the so-called GMCB project back in 2006 showing that those researchers, they were only able to reproduce 7% of the papers they tried to reproduce. Okay, more recent empirical evidence, again coming from economics, Gertler and co-authors. Again, a few hundreds of papers, well published. Long story short, they are able to run only 14% of the code. Okay, so I'm not talking about regenerating the same result, just running the code. 14%. Another paper by Chang and Lee in the American Economic Review. Again, 1/3 of the results have been regenerated, and they use a way less strict definition than the one we use here. So it's really surprising. More recently, Lars Willhuber and co-authors, they pick all the accepted papers in the American Economic Journal, Applied Economics, and they use a battery of undergrad students. They exclude papers for which the data was not able to generate. So, and they only reproduce 40%. Okay, so that's the current situation, In this paper, we do the same thing from our field, from finance. So we're going to take a bunch of finance papers. And the first thing we're going to do is, just like the other researchers, we're going to try to assess the level of computational reproducibility. But that's not the only thing we do in this paper. This is just the first step. To present a little bit our result, we'll see that we don't have a very high success rate. It's way higher than the one I did show you, but it's not 100%, which is puzzling. Again, I have the same data, I have the same code, I'm not always able to regenerate the result. It's very puzzling. So why this is the case? Those are the next 4 steps. We try to list all the problems we faced, the problems we have been able to solve, and we solved quite a bit of problems, and the one we were unable to fix. And then we try to study the cross-sectional variation across papers in terms of computational reproducibility. What are the drivers? What are the deterrents of computational reproducibility? And then one thing we do, we're going to ask researchers ex ante, do you think your research can be reproduced? And then we'll be able to contrast this with what we find empirically, ex post. And then we're going to ask, that's my last step, about the difficulty. Again, I'm asking the researcher, what do you think? Is it going to be difficult, challenging to reproduce the result? And then I'm going to ask my verificator ex post, and often, again, they will disagree, as you will see. Okay, and one unique feature of this paper is the fact that this is an experiment. We run the whole thing in the context of a large-scale experiment. What type of experiment? It's a crowdsourcing study, and we're proud to say that this is the first one in finance. And the way it works is the following. We have a large number of teams, 168 research teams, and we gave to those guys the same data set. It's a ridiculously large data set of 1 billion, close to 1 billion transactions. So it's the most liquid financial product in Europe, Eurostoxx 50 futures, and we have over 18 years all the transactions, intraday data. It's ridiculously large. And we asked those guys, use this data and ask the same 6 research questions. Again, this is finance, this is microstructure. We study how transactions happen on financial markets. We ask questions about market efficiency, about beta spread, about trading volume, about the type of orders they use, or who's making money, who's losing money on that transaction. Same research questions. And that was the first paper, the 353 co-author paper, was about studying the differences provided by those researchers and then understanding why, what are the methodological decisions that they had to make when they disagree, etc. And then we provide them with some feedback, reviewer comments, and then they have the opportunity to update their result. And we can see this cross-team variability shrinking as we provide them with some feedback. That's a previous paper, but we use this as the raw material for the paper I'm going to present now. Because they had to answer this question, but also had to provide the code associated with their paper, and they also have to provide a paper describing the answers to the 6th question. And because we have 168 teams and 6 answers, I end up with a super large number of empirical findings for which I can test and I can assess the computational reproducibility, hence the paper hence the title of my paper. Okay. So again, step 1, let's assess the reproducibility of this 1,000 plus results. We ask, so as it was mentioned in the introduction, I'm leading Cascade, which is a certification agency for reproducibility in France. So we have several professional, like full-time verificators, and we tasked one of them for 4 months. The guy was full-time on this. He had to go through this 168 code and try to make them run. He was able to get virtually any software he needed, virtually unlimited CPU. He could get some help from the IT team of the various universities we work in, but he was unable to talk to the authors. Because it was part of a large-scale experiment, we didn't want to mess things up. And another thing in that he was able to spend 1 week max. So the average CPU time was 7 hours. The median CPU time was 3 hours. So he had 1 week, okay, maximum. And then for each result, we produce a so-called reproducibility score, although, so it goes from 0 to 100 when we have perfect accuracy. So it's 100. And if we have only small differences, it's 75. Small differences at most 10% difference with the original result. One large difference, it drops to 50. Several large differences, 25. And when we are unable to generate any result, the score is 0. And then we have the associated reproducibility rating with triple R being the best you can think of. Okay. And here is the result. We have 52% of 100. And we have 29.1% of 0. And the rest is in between. So we have this bimodal distribution. This is for all the 1008 results. When we break down by research questions, we always see this kind of U-shape, all of them. It's interesting to see that question 3 and 5, we have a much higher success rate, another 10 percentage point. And those questions are, interestingly, the easiest one, the less ambiguous one. So that's why it's not coming as a big surprise. So we can also compute the average reproducibility score per team across the 6 research questions. It goes anywhere between 0 and 100, as you can guess, with an average at 63.5. So is 63.5 high or low? We have kind of half empty, half full glass type of problem here. So I could say on the positive side, it's way higher than anything else I've been able to see in the literature. So I'm kind of happy. Although this is a very complex situation, like the data is incredibly large. This is an area where the code and the code that we need to develop and implement to process the data is very complex. So it's not bad. But on the negative side, I can say that, hey, wait a second. I have the code, I have the data because I gave them the data. Yet, many of these replication packages are not running because of bugs, lack of information. I'm going to elaborate on this in a second. And when they run, they don't produce the result I can find in the paper, okay? So all this hard to run code, they really impose a cost, a collective cost and a massive one on the whole research community because everyone who want to run this, they will have to face all the problems that we face, so it's very costly. And some of them are not working. So it creates like a negative externality. You think about a PhD student like running those code and then unable to say what this scientific field is about. So it's really problematic. So the rest of the analysis here is to understand why we have this, we don't have a success rate of 100. We analyze all the problems we faced. As you can see, 46% of the results, we were unable to generate the results. Okay. When the first time we tried, and then the verificator, he was able to change the code a little bit to get some new software, to change the version of the software, etc. So by doing so, he was able to save another 17% of these results. So that's why we end up with only 29.1% of zeros. Okay, and then for every single problem, we were able to classify them. It's either problem affecting the code, software libraries, README files, CPU, memory, data. And again, systematically, we have the problem we can solve, the problem we are unable to solve. Okay, and then we end up with a typology of all the problems. We have 20 categories. So for each of these 5 families, we break down and explain what happened and how often this happened, whether we have been able to solve, whether we were unable to solve them, etc., etc. Okay, so that's interesting, in my opinion. Another thing that we did, which was kind of interesting, is that that's an experiment. So I'm not working with actual published papers. So as a test of the external validity of my experimental results, we use 60 actual publications typically published in American Economic Review, American Economic Journal, also economic journals, because again, the data editor of these journals, they send us cascade this publication, and they ask us to reproduce the results. The funny thing is that it was the same verificator than the one we already did, the 168. So it's kind of a meaningful comparison, in my opinion. And the interesting thing is that we have the same success rate when I'm using actual publication written by top guys, Ted Miguel and other of his top economists. And we also have kind of similar type of problems, although we have fewer problems affecting code with AER publication and many more problems affecting the data. Of course, I don't have a lot of data-related problem because I have the data and I gave the data to the authors. Okay. And then we move to the next one. We try to understand what are the drivers or deterrents of this reproducibility or lack of. And then we have a lot of information about those guys. Thank you. We have information about a lot of characteristics and skills of the researchers, the type of research question they're working on, the software they use, the complexity of the computer code. We went through the computer code and we analyzed it, the quality of the research. We have 20 senior reviewers in this experiment, and each paper has been assessed twice. I also have another proxy for the quality of the answers. We have some proxy for the effort made by exhibited by the researchers themselves. So a lot of information. For academic quality, we know the seniority. We know whether they are tenured or not, whether they publish in top 3 finance or top 5 econ. We have the number of citations. Again, we ask them to self-assess the expertise in several areas related to this particular research. For the coding and data handling skills, again, we ask them to self-assess their skills in terms of managing large database. And then we check the code. We check whether they use parallel computing, whether they use advanced coding techniques, whether they use loops or matrix notation, etc. We know the composition of the team, the location, where they come from in terms of academic affiliation, the software they use. A lot of information, code complexity, whether they use a master file, whether they need some help from us, the number of software they use. Some of them, they use 5 software. It was a nightmare. The size of the software, the number of script files. Some of them, they had 85 script files that we were supposed to run. Again, my verificator, he resigned 3 times during the experiment, but he's still with us. CPU time, again, the median's supposed to be around 3 hours. Some of them spend they take more than 1 week. Research question assessment by some senior guys from the profession. Documentation quality, whether they provide information about the software requirement, the computer specification, instruction to reviewers, whether they help us to locate the results in the log file. Sometimes they don't and we struggle. Whether they mention the runtime, the quality of the README file, and the size of the README file. So a lot of information which we can plug in a regression analysis. And then again, we try to explain the level of reproducibility for every single result, 1008 data points here. Academic quality doesn't help. If you have a super top guy from a top institutions or more like a PhD student from a second class institution, no difference. Coding skills really helps. So because we have like 4 variables, we use either like a principal component and we just use the first PC, or we put them independently. So that's the difference between model 1 and model 2. Quarter doesn't help, gender, location, no effect. Software, we were expecting, some software being positively associated with the capacity to reproduce the result. It's not the case. Research question, again, the easiest question, the less ambiguous question, it's way easier to reproduce them. And then we also add some extra information about the assessment from the referees. No effect on the capacity to reproduce. And then we have this next result, which is outliers. We have some, whole distribution. And then we struggle to reproduce the results which are in the tail of the distribution. Okay? We use a 2.5 threshold on each side. But what we show, and that's a result I find pretty interesting, so I want to show that it's very significant, and we were talking about with Guido earlier today about the statistical significance, also the economic significance. The magnitude of the coefficient is super high. We talk about 30 percentage point. I mean that the likelihood of us being able to reproduce goes down by 30 percentage point if I try to reproduce some result further in the tail of the distribution. And if I use 5%, or if I use 10% or 20 or 30, I always have some significant result. Okay? So here is the most, maybe simpler and very impressive graph here. Here, I just have these sides of the point estimate. And this is a percentage of fully reproduced result in this decile. It's 40%. It's also around 40% in the top decile. This is the right tail, this is the left tail. And this is 70% in the center of the distribution. So huge differences. It's pretty fascinating results here. We also have some a strong negative effect of complexity with a p-value of 0.06. Document quality, all the effort that they spend is also useful because it's helping us to reproduce a higher level of reproducibility. My last 2 points are the following. We ask every single team, what do you think? Are we going to reproduce your results? So answer A is you will find exactly the same result, or maybe minor differences, major differences, or no way, don't even try, you have no chance. And then I see that for only 27% of them, I have full reproducibility, all the 6 results, that's fine. And here I have 29% of them, they told me it would be the case, but 7.2% of them, they told me no, and yes, we have been able to. So they are like, they are underconfident. And if I look at the guys for whom we're unable to reproduce, we have 70% or so. 49.4% of them, they were like very confident. Okay, so this is consistent with some kind of a massive overconfidence. And I'm jumping to the last comment, which is about the difficulty to do so. And then we ask them how difficult it would be to reproduce their result. It's either straightforward, quite easy, challenging, or very difficult. And then we present the result like this. This is what the researchers tend to think. This is what my verificator actually told us at the end. And sometimes they agree. This is the diagonal here. But we have where we have the most mass here is the below diagonal cell here. So we have 40% of the whole mass below here. Again, this is an understatement of the difficulty of our job here by the whole. Yeah, I think it's time for me to conclude. There is maybe the one thing I wanted to say that we talk about a very serious problem. Again, those replication packages, they do not always run. When they run, they do not systematically reproduce the result. We try to understand in this paper why this is the case. And again, it's resonate quite well with all what you guys are doing at BEATS here, because we show that coding skills help. We show that having, spending time on the README, it's also, positively associated with our capacity to reproduce. And what we need here is to boost that through training and communication. That's exactly what we do here. And also the fact that us collectively, researchers, we don't understand how difficult it is for other researchers to reproduce the result. Again, we need to inform them about that. It's going through training and communication. I'm going to stop here, and thank you very much.
I don't understand that survey where you ask people to say if they think they can be reproduced. Like I cannot put myself in the shoes of someone that would say no. Like maybe it's just me being naive and being more junior and growing up in this open science stuff. But why would anybody say that you can't reproduce their work? It would almost feel like, oh, why did I submit it in the first place? I should fix it until I can say yes. So maybe it's a finance thing and I'm more psychology. I would love to know why.
Yeah, no, that's a very good point. And it's true that this is likely to be biased because it's very hard maybe for someone kind of to plainly say that, you know what, I don't think you will be able to reproduce. But what we have here, we have some researchers using some very peculiar software. We had some proprietary, we had like 350 researchers. We had like a huge distribution. Some of them came up with crazy, so surprising or exotic software. Other, they know that they did not provide maybe enough information, so they anticipate that we may struggle. If you ask someone like us with some knowledge about this whole thing, we may kind of admit that it's not always possible to reproduce, or maybe you can say maybe some minor discrepancy may arise. I don't know. Yes.
Thank you. One thing I just didn't quite catch, did the people know that the main goal of your study is to reproduce it? Or did they think that it's just a meta study of what people in the finance world think about these 6 questions? What did they think you were doing?
We didn't tell them anything. They knew that they were participating to the first study, the 353 author study about the cross-sectional variations and about the dynamics of this distribution through time. This they knew. They knew that if they did follow the 4 stages, they would become co-author of the paper. They knew that senior members of their profession would read their paper, knowing their names, so they had strong incentives to provide, to do something very serious, and kind of when they receive feedback from some top guys from the field, they had strong incentives to update in a very serious way. This they knew. They did not know about the second project that we did, but they knew since day one that they had to provide the code. So it's very similar to what we do in finance. In finance, we have to submit the code, but we don't. So in the top 3 journals in finance, there is no verification, unlike what we do in economics. But that's very similar to what those guys did. They knew that they were submitting their code, but they did not know what's going to happen next. Very similar to the real life. When we publish in top 3 finance journals, we submit the code, we don't know what's going to happen.